Hello, in this section I will continue from Coulomb's law. So in last talk I left this equation 4, which is the representation of the force in terms of the vector form. So now we have to note some points here. The unit vector AR is in the direction of line joining these two charges. So in case of like charges, the unit vector AR and force of F are in the same direction, and you can see here. So in case of unlike charge, they are in opposite direction. So you can see here, if the charges are same, we have this charge plus Q1, and this is another charge plus Q2. So the line joining these two charges here. So in case of like charge, this F2 and the unit vector AR, so they are in same direction. But what is the case when these charges are unlike? So in this case, the force and unit vector will be in opposite direction. So this is charge plus Q1, and this is charge minus Q2. So in this case, the force direction will be here F, but the direction of unit vector will be opposite. So this is the case when charges are unlike. Second is, if there are number of charges acting on a test charge Q, then the net force will be the vector sum of individual forces. We can say F1, F2 and F3 and so on. So let there will be n charges, you can say n charges Q1, Q2 and Q3 and so on Qn. So located at a point with position vector R1, R2, R3, Rn. So the resultant force F on a charge Q located at point R will be equal to F equal to 1 over 4 pi epsilon test charge Q, Q1 R minus R1 modulus of R minus R1 cube plus 1 over 4 pi epsilon naught Q1 Q2. Sorry, this is simply Q and Q2 R minus R2 divided over modulus of R minus R2 cube and so on 1 over 4 pi epsilon naught test charge Q, Qn R minus Rn divided by modulus of R minus Rn cube, and you can write this equation as F equal to Q divided over 4 pi epsilon summation I equal to 1 to n Qi R minus Ri divided over R minus Ri cube. And next point is, if instead of air or vacuum, some insulating materials like glass, wax, paper, oil, and so on, so is placed between these charges, then the force acting between them will be F equal to 1 over 4 pi epsilon. So we are not taking here, we are taking here epsilon Q1 Q2 over R square. So this is the case when we have some other dielectric materials, insulating materials, instead of air or vacuum, we have this expression of this force between the charges Q1 and Q2. Now I have this simplified form of these different forms of Coulomb's law. So you can see here the general formula of Coulomb's law is F equal to Q1 Q2 divided by 4 pi epsilon naught R square equal to K Q1 Q2 over R square. And in vector form we just put here a unit vector AR. And in a median form, if we have these some insulating material between the charges, then the expression we have already shown in the last slide, F equal to Q Q2 divided over 4 pi epsilon R square unit vector AR. So this is the different forms of Coulomb's law in vector form, in general form, and in a medium. Thank you.